All right, welcome everyone to a foggy Tuesday morning in Houston with my Period 4 statistics class. We're going to be talking about confidence intervals for proportions. So this isn't on your sheet, and I don't expect you to write this down, but I showed you this, guys, last week when we did chapter 18. This is what you're going to be doing. All right, this is what you're expected to learn by the end of this week. Again, you don't need to write it down, but just wanted you to see that these are the 4 things that we're going to be accomplishing this week with confidence intervals. All right, so let's get started. All right, when we ended last week, we were talking about sampling distribution models for sample proportions and sample means. I'll repeat that because it's something that it's a long thing to say. Last week we talked about sampling distribution models for our statistics. That would be proportions or means. So you'll notice here the standard deviation that we used was a little different than what we had used in the past. We have standard deviation, and do you guys see these symbols in the parentheses? Those are the statistics. P hat stands for the sample proportion, and Y bar is the sample mean. Okay, so this is what we used last week. The reason we can't use that this week is because most likely we're not going to be given the population mean, the population standard deviation and the population proportion. All right, that's usually in the world. Unlikely you'll ever know that. All right, so what we do is the next best thing, which is we estimate it by using our sample statistics. Okay, so that's what we're going to use this week. But you'll notice there's a change then in how you write it. Do you guys see how this SD became SE down here? So that means standard error. Okay, so make sure when you're writing these notations this week, you understand why we're writing SE and not SD. All right, so standard error instead of standard deviation if you're estimating any population parameters. Now, I put both on here because we talked about both last week, but going forward for the duration until the end of this quarter, we're only going to care about proportions. Okay? When we come back from spring break, then we will talk about means again. All right, so from now until spring break, it'll be proportions. Yes.
When is spring break?
March. So not this month, but next month. Okay. Me too. All right, so let's talk about what a confidence interval is. All right, since we do not know what the population proportion is, and probably will never know, what we do is we make a statement about where we think it might be based on our sample that we were given. Okay, so a statement you'll hear today is, I am 95% confident that the true proportion of all voters who will approve the school budget for next year is between 0.4 and 0.6. That's a statement we're going to write, not exactly that, but similar to a statement we're going to write today. Okay, so we can talk about how confident we are that we have captured or trapped the true population proportion P. Will we ever know if it's in our interval? Will we ever know if it's in our interval? We will never know. Okay? That's why we say that we're 95 or 90 or 99. We have a confidence level that explains how wide our interval is. Now, what this means, right, and this is where I want to make sure you're understanding what I'm talking about. What this means is it's either in our interval or it's not. All right, so students incorrectly will interpret that percentage of confidence as a probability that it's in there. I'm going to say that again because it's important. Students will incorrectly interpret our level of confidence, so like 95%, as a probability. I don't want you to think of it as a probability. All right, what I want you to do is I want you to think of it as imagining running many confidence intervals over and over and over again based on different samples. All right, I like to use the example of what if I wanted to sample 50 students out of all the Cristo Jesuit students. Okay, so I do one sample. So imagine who's in this sample. Okay, and then I put them back. I do another sample. Am I going to get the same students? Probably not. Maybe there's a one or two or a couple that are in both. But most likely, if I did it over and over and over and over again, I'm going to get very different groups. Okay, and if I make a confidence interval based on each of those samples, I'm going to get different intervals. Okay, so that one that I starred is how I want you to interpret the confidence level, that 95% of all of the intervals that we make will contain the true proportion. That's what we're saying. All right, we're going to do that a lot this week. Now, this right here is what a confidence interval is. You're basically saying, here's what I think the true proportion is. That's your estimate. And you're going to see, we're going to use the sample statistic, which is p hat. We think it's that. But since we're not 100% confident, we give you you know what? It's that, but it could be a little bit above it or a little bit below it. All right, and that is what's called the margin of error. That capital M, capital E is called the margin of error. That allows us that wiggle room because we're not saying we're 100% confident. Now, you guys have probably read something. If you've ever looked at any type of polling, they will always look in the fine print. It will say what the margin of error is. All right, which is when people were all going crazy about the polls, blaming the polls for Hillary Clinton losing the 2016 election. If you read the fine print, you would have seen that the polls were not wrong. It was just unlikely. But it's still, they said it was possible. All right. Okay, now, there's always a battle or a struggle between how confident you are and how accurate or precise you are. All right, so I want you to imagine that this is my trap. Okay, everybody imagining that's my trap? I'm 95% confident that we've trapped the true proportion in this trap. Is everybody with me? Okay. Now, I would like to be more confident than 95%. So how would I change my trap to say that I'm more confident that I'm trapping it? No, I'm telling you it's 99%. So this one is 95% confident. I'm 95% confident that somewhere in this trap is my population proportion. Now I want to change it to 99%. What kind of trap would I need to capture, be 99% confident that I'm going to capture it? Say it again. See, that's what most students think. Most students think it's smaller, but I am actually more confident that I'm trapping it, right? So if I'm more confident that I'm trapping it, I actually need it to be bigger or wider. That's and I'm glad you said that, Yesenia. That's the difficult thing about this is that usually students go with, oh, it needs to be smaller. But actually, no, if you want to be more confident, you need to have a wider net. All right? If you want to have less confidence, then you can have a smaller net. There's always that struggle. There's always that balance between the idea of precision and the accuracy. Okay. These two down here are the ones that I'm going to make you memorize and that we're going to use most often, 90 and 95%. They're the most commonly used confidence levels. So here's a kind of a way that I remember it. For 95% confidence, our critical value is going to be 1.96. All right, so my brain just thinks, what comes after 95? 96. That's how I memorize it. All right, and the other one I just memorized. 90% is 1.645. Okay? So make sure you memorize those for our quizzes and tests. All right, the last couple of slides is to show you, all right, what we have to do before we run it and then what it looks like to actually run it. Okay? Now, what did we do last week before we made any sampling distribution models? Made assumptions, and we checked the conditions. Well, guys, they're back. All right? Now, before you get sad, just take a quick glance here. They're the same. So I haven't changed anything on you. All right? Yes, we still have to do it, but they're the same. All right? And since we're talking about proportions, you see this one at the bottom here? When we talked about means at the end of last week, it was about the large enough sample condition. But since we have proportions, we're going to go back to success failure. That's the n times p and n times q being 10 or more. All right? So I'm going to do that again. Okay, so here it is. This right here is the notation of what it looks like to make a confidence interval. So make sure you write it down. So we have our statistic or estimate, which is p hat. Make that a little nicer hat. So our statistic or estimate, which is p hat, plus or minus. All right, it's plus or minus because we're confident that it's p hat, but we're not 100% confident that it's exactly that. So we go up a little bit and down a little bit. That's the plus or minus. This c star is our critical value. All right, we're going to multiply that times our standard error for our statistic of p hat. All right, and if you remember from a previous slide, this right here, z star times the standard error is called the margin of error. So z star times the standard error is called the margin of error. All right, so whatever's after the plus or minus is your margin of error. Now, the last part of that slide talks about what to do if you would like to actually figure out the sample size you need to run a sample. All right, because ultimately, if you end up doing this for your job, if you're a pollster, you have to actually decide what is your sample size going to be. So you would pick a confidence level. So how confident do you want to be? 90, 95, 99, okay? You need to pick a margin of error you're comfortable with, 1 or 2 percentage points, 5 percentage points, something like that. And then you're going to use the idea of this being our margin of error to solve for a sample size, the letter N. We will do that together, not today, but we'll do that tomorrow together. Okay? Any questions before we try one together? Are you guys ready? All right. Now I tried, just like last week, to make these a little bit larger. So if you flip, you should see 2 large boxes. In the first box, this is where we're going to do what? What we're going to do? Assumptions and conditions, all right? So what is an assumption you remember from last week? The independence assumption. Let's write that down. Now, after you write it down, take a quick read of this problem. We're talking about a local newspaper is polling a random sample of 330 voters. They find 144 say that they will vote yes on the upcoming school budget. Create a 95% confidence interval for the actual sentiment for all voters in your area. All right, who wants to give it a try with a sentence about independence assumption? Who wants to give us a try with the sentence of what could be a sentence for assuming independence here? Susanna? Absolutely, there you go. Sounds good. One person voting will not affect the other person's vote. So like if somebody votes yes, that's not going to affect the next person. Or if somebody votes no, that won't affect anyone after or before. So you want to write that sentence down? One person's vote does not affect another. Now, do we know if that's true or not? Do we know if that's true or not? Because what if they just asked 330 voters that lived in the exact same neighborhood? All right. Or what if the 330 voters were all from the same work office, like a big company? Right? We don't know. We think that's okay, but we don't know. So what do we check to make us feel confident that we're making a correct assumption here? We check the randomization condition. Okay, who wants to give that a try? Anyone? Randomization? Yeah, Kelly? Done. Perfect. Boom. Good job, Kayla. They said it's a random sample. They took a random sample of 330 voters. Perfect. So hopefully you wrote down, they took a random sample of 330 voters. What's the other condition that we can check? The 10% condition. Very good. Now this one is where I require some math. So let's go ahead and ask ourselves, what is the sample size? 330. What are we going to do with that? Multiply it times 10, and what do we get? 3,300. So I don't know where this local newspaper is from, but are we okay if we just assume it's from Houston or Harris County? Okay. Now I know that some of you, including myself, don't live in Harris County. All right, that's okay. We're still good people. All right. Now, when you think about Harris County, Houston, are there more than 3,300 people that are registered to vote? Yes. All right. So what we're saying here, the sentence you're writing, is our sample size of 330 is not too large. Our sample size of 330 is not too large because we think it's less than 10% of the entire population of registered voters. So the way I always think of it is we have 550 Priesthood Jesuit students, right? Something like that. All right. 10% of that is 55 students. So if I have a sample size of 180 students, that's more than 10% of all the Priesthood Jesuit students. So I violated this 10% condition. Okay? So that's a problem. All right. So we just said the sample size of 330 is not too large. Now let's make an assumption about it being what? Not too small, or what I like to say is large enough. So that's what I'm writing down for the sample size assumption. You're writing down our sample size of 330 is large enough. The sample size of 330 students is large enough. What condition can we check? What condition can we check? This is proportions, so we're going to check success failure condition. All right, so we're going to multiply n times p and n times q. Oh, wait. Hold up. I know n is 330. What's p? What's the population proportion? That's a confidence level. That's not our population proportion. The population proportion would be out of all the voters in Houston. Say it again. Okay, so what Susanna is saying is she's going to use 144 said yes, so success, and the other amount said no. That's totally fine. You can do that. But I'm still haven't heard the answer to the question. what is the population proportion of all voters in Houston that are going to say yes to the upcoming school budget? The answer is we don't know. I don't know what P is. Did they call everybody? No, who'd they call? This sample. All right? So we don't know P. I'm going to write that up here. We don't know P. We don't know it. And guys, it's okay. It's going to be all right. All right, so let's go ahead and use what Susanna told us. She said that she's going to use 144 to be success. So what's 330 minus 144? Do you need a calculator again? 186. I heard 186. Are both of those numbers 10 or more? They are. So our sample size of 330 is large enough. Okay, now I'm going to write a statement that we haven't written before. You guys ready? Okay. Yeah, Julius. Yeah, that part's for another thing. Try not to go in that box. If you've already gone in, try to stop going in. Okay? Here, I'm going to type. You ready? Here we go. The conditions have been satisfied. The conditions have been satisfied. So I will use the normal model to run a one proportion. So I will use the normal model to run a one proportion Z interval. Okay? So basically that's a sentence that tells anyone reading, hey, I've done my due diligence, I've made my two assumptions, I've checked the necessary conditions, everything seems okay, here's what I'm going to do. Any questions on what that statement is saying? Now, there's a couple things you may not see or might not understand. The Z interval, the reason I put Z in front of that interval is because we are using the normal model, so we're talking about Z scores, right? Z star is what we're going to use for our critical value, but when you think normal model, you're thinking Z for Z scores, standardizing. Okay? So that's why it's Z there. You can probably imagine that at some point later on in this class, it's not going to be Z. There's something else. All right? But that's why, for now, it's Z. Shouldn't have any other letters but that. All right, are we ready for the math? All right. So, first thing I like to do is I like to write down the formula for the confidence interval. All right, and this is ripped straight from your notes, okay? This was P hat, all right, which is our statistic or estimate, plus or minus Z star times, now why are we using SE? Why are we using standard error, not SD? Did we know the population proportion? Remember I wrote we don't know P, so that's why we're using standard error of P hat.
Isn't the other box?
This, I'm sorry, yes, I went to the next box. Sorry if that wasn't clear. Should go to the next box now. My fault, sorry about that. Sorry. Now, how do I find P hat? How do I find P hat? What is P hat? What is P hat? What is P hat? P hat is the sample proportion. The sample proportion. Well, how many people did they call? 330. How many said, yes, I'm going to vote to approve the upcoming school budget? What was it? 144. Take your calculator and do 144 over 330. And I'm getting 0.436. Did everyone get that? Do you want to use 0.44? That's fine. It doesn't matter. Let's use 0.44. Susanna said 0.44, we're going to use it. Okay? So where did I get 0.44 from? 44 from us. Where did I get this p hat from? I divided out of a total number of people that they called. How many were successes? 144. Questions so far? Plus or minus? Ooh, what Z star am I going to use for a 95% confidence interval? 1.96. Very good. Again, I expect you to memorize that number. 95% confidence interval, use Z star of 1.96. Okay? Times the standard error of p hat. The formula that you guys have in your notes says the square root of what? So it's PQ over N, but do we know P? If we don't know P, we don't know Q, but we do know P hat. So we're going to know times Q hat over N. All right, and the reason that this says standard error and not standard deviation is because in the formula we're using sample statistics. We're using the hats. All right, so that's kind of the link that I've tried to do when I was in high school, was if I see hats in my formula, right, in the formula part, not here you see hats in both. If you see hats in the formula, I should see standard error. Hats in the formula, standard error. Okay, so times the square root of 0.44 times, what's Q hat? What's 1 minus 0.44? Not 66, 56. Got to carry that 1. Over sample size? 330. All right, now it's time to go to the calculator. And you can do this like in 1 step, 2 steps, whatever you'd like. So I'm going to keep 0.44 plus or minus. Let's do fraction in my square root. 0.44 times 0.56 over 330. So I got a standard error, if I round, of 0.03. Yes, did other people get that? And then times 1.96. Okay. I got 0.054, I guess. All right. So if I do 0.44 minus and plus 0.05, this right here, 0.44 times 0.56 over 330, the square root of that. I rounded. It was 0.027. Do you want me to write 0.027? I can. I'm not that worried about it, right? It's just rounding. I see. Okay. Now, I'm going to write another statement. I'm sorry. Get some water, get some rest. All right, you guys ready for the statement? Okay, here's the statement. And then you're going to pull out your phones. Okay. I am 95% confident that the true proportion, I am 95% confident that the true proportion of all voters who will say yes to the upcoming school budget. So I'm 95% confident that the true proportion of all voters who will say yes to the upcoming school budget is between 0.39 and 0.49. Now, do I know if that's true? Do I know if I've captured the true proportion of all the voters who are going to vote at the upcoming election? I don't. Either I've captured it or I haven't. So what's really nice is after the results come in for that day, I can see if my confidence interval captured it. We can see if the true proportion is somewhere in between those two. All right. Questions? All right, so I want you to take out your cell phone. I'm going to send you an email with a link. All right, I want you to click it. And again, you shouldn't get any viruses, but if you do, that's my B. Okay, I'm not going to pay for your whatever it takes to get it fixed. So sorry about that. Yeah, go for it. All right. Is this you guys? Yeah. All right, so go to your school Gmail and open this link. Hopefully it looks like this. I'm going to make it a little bit larger so you can see. Can you guys see this? Did it open for you guys? No one's speaking. Did it open for anyone? No? Yes? Okay. So what am I going to put in the sample size? 330. Very good. How many successes did I have? 144. And you see the confidence level is 95%. That's what we did. So leave it and then hit calculate. And I want you actually to scroll down to the second one where it says normal approximation, because that's what we're doing. We're using the normal model. I want to point out a few numbers. You guys see the 0.36 p hat? We rounded to 0.44. Do you guys see the 0.383 lower value and 0.49 upper value? That's our interval. Do you guys see the 0.027 number? That's the standard error of, it says mean, but for this it's proportion, so it's standard error of the p hat, which we said 0.027. And then you see the 1.96, that's the z star. So everything is there. All right. So tomorrow when I have you guys working in groups, I'm going to allow you to have your phone out to use this. Actually, I think I'm going to have computers if you like to just use the computer, but you can use your phone. And your calculator as well, so you can kind of do all this at the same time. Because in no job that you have will you not be able to use the best technology out there. Okay? Any questions on this? All right, so that concludes our lesson for today. Thanks for watching. All right, tune in next time about z-tests.